Okay, now we're going to begin some of our first measurements or setting up our first measurements for stochastic resonance. We have to make sure though we get the noise centered on the hysteresis width, which I will show you how to do. So let's just make sure that it's working again. Go to triangle, and we're getting that Schmidt trigger like we got before. Now, the thing is that this noise is going to be right around the width of the hysteresis, right? A little bit less and a little bit beyond, and as we do the experiments. But we want to make sure that we're kind of in the zone, the middle of the hysteresis width. So what I'm going to do is, we'll have our auto measurements. Okay. And I'm going to, right now we have peak to peak of 4. I measured a peak to peak, a hysteresis width of about 0.5 volts. Now, actually we measured it, estimated it more closely to be 0.43, but it's better to start a little bit larger. So what I'm going to do is decrease the amplitude here, all right, until I get close to 0.5, which, if I recall, was about 13. All right, so that's 573 millivolts. And I think for me, again, if you might have slightly different settings. All right, 521, great. But notice, this is not tripping. So I'm going to raise this until I get to be about the middle of where the hysteresis width should be, which should be an average of 2.5 volts. So, which was near 55 for me last time. Okay. So, my average is, it's really jumping around because it's not even periods. So what I'm going to do is, I'm going to try to take 20 milliseconds worth of data. Let's see if we can get a little better average. That doesn't jump around. All right. So that's 2.5. And you can see that it's spending about half the time high and half the time low. All right. I'm just gonna, I just went down by 1 and it stopped working. 55 was working, and 56 was not working. So that DC offset is kind of like, for this particular measurement, is right where you want to be. And this setting of 12% is giving a peak to peak of 469, which, yours might not work there, right? So I'm just going to bring it up to 13, right? And now it's working. And if it's not working, yeah, you can kind of make it bigger, right? But notice it's spending more of its time low than high. And because this doesn't go symmetrically about that point. So let's go back to 13 and remember where we are. Okay. So now, now we're kind of in the right zone. However, we're not inputting the noise. We're going to test the system with just noise first. And really, all we have to do is put noise here. All right. And now you can see it's still spiking. It's just not necessarily even. You know, the average is 2.5. The noise and the triangle wave are not the same signal. So I'm just going to try to decrease this. Well, the peak to peak of the noise is still 521. But I can keep decreasing that until it stops working. So for me, that peak to peak of that noise is working for 12. You might have to increase or decrease that. All right. And that's my 50% spot. Now, yeah, does it still work if I go up lower or higher or lower? No, it is only working right there. Okay. So now that noise is causing a noise pattern through the bistable Schmidt trigger, which we can characterize. And all we have to do is Tools, Export Waveform, and save it to your desktop. And you can name it anything. All right. I'll just call it full width half maximum. All right. So that's actually one measurement. All right. And actually, anyway, I'm just going to show you that one. So I'm going to end it here, and then I'm going to show you how to process it in the next video.